Hi, this is Eddy Prieto, and this is my Lab 5 Motion of Falling Objects. For this lab, I observed a soccer ball and a paper plate as they fell and the effects of gravity and drag on them. The soccer ball was my fast moving object, and the paper plate was my slow moving object. In the first video, you get to see the fast moving object, the soccer ball, as it fell, and I used the tracker program to track the center of the ball as it fell, and then use those data points and exported them into Excel for later use. I basically did the same thing with the paper plate, tracking the center, and then using the data points and exporting that into Excel as well. Okay, next thing I did was I went to go model this experiment in VPython, and I first modeled it without the drag force here, and I did that by commenting out the drag force, and that made it just so that the force of gravity was used in updating the velocity used in the momentum principle. So I commented that there for the fast, and I did it for the slow moving as well. But for the sake of time, I'm just going to show you the model with the drag. This is of the soccer ball falling, as you can see there. And this is it for the paper plate moving. You can see that one's a little slower. Okay, now you can see the data points that I have here. We'll start off with the no drag. The position of the soccer ball, they were very similar even without the drag, and that is because drag didn't really have that much of an effect on the soccer ball falling. But when you put it for the position of the plate, you can see it had a very large effect, and that is because of the area of the plate as it fell. And the computational is just gravity, so it's moving at the same rate, at the same acceleration, sorry. And the experimental data is obviously very different. Now we go to the with drag, and you can see the plate and the computational are very similar, and that is because of the drag component. And the drag component did in fact make it so the computational is more accurate. And then when we move over and see the soccer ball is about the same. It's still very accurate, and that is with the drag. Now we do the what does it mean question. For the what does it mean question, it asks, for the object that drops slowly, examine the velocity versus time predicted by your models with and without drag. Which models predict the terminal velocity? Alright. For my slow moving objects, here you have the position of the plate. You have them both on the both graphs, sorry. And I do believe that the the model with the drag reaches the terminal velocity, because terminal velocity is basically when drag is equal to weight, and then the object will be moving at a constant velocity, also a terminal velocity. So using that definition, it's easy to see why the model with the drag will reach terminal velocity. The next question is the what if question. For the object that drops slowly, use your models to examine the object's velocity in the case where the object is thrown downward initially. In this case, is the object reach a terminal velocity? I think that if we did in fact put a force on throwing down the paper plate, it would reach a terminal velocity faster, because of an initial force would speed up the plate quicker, which would make it get to the terminal velocity faster. And I think that's it for those questions. And in conclusion, my main result was that all objects do fall at the same rate because of gravity, but an upward drag does act on them, which is proportional to their speed. And that's it for my Lab 5. So hope you guys liked it.